Today's video is on domain and range. For domain, you're going to scan your pencil from left to right and identify the X values in which you are touching the graph. So domain are the X values. That's important. The range, we're going to scan our pencil from top and bottom and identify the Y values, which are on our graph. So it says, note, domain and range of these types of graphs are usually written using inequalities, which remember was like less than or equal to, or less than, greater than or equal to, or greater than, or using interval notation, which is where we use those brackets when we had less than or equal to, or greater than or equal to, or we used parentheses when we had just less than or greater than, or we also use parentheses when we were talking about negative infinity or positive infinity. So we're finding the domain and range of continuous graphs. So it says identify the domain and range of each graph. So if I take my highlighter here and I scan it from left to right, notice the X values would go forever to the left because there's an arrow there, and forever to the right. So for the domain, I would say that our interval is negative infinity to positive infinity. Another thing you may see this called is all real numbers, because any X value is on this graph, any of them. Right? It goes forever, left to right. Now, if I were to scan this from top to bottom, notice it starts here and goes up forever. So we need to figure out what this starting point is. So that's at -2. So the Y values on this graph are just -2 and anything above -2. It does include -2, right? There's a point there at -2. So I'm going to use a bracket, and I would say it includes -2 and anything bigger or going up. So that would mean it goes all the way up to positive infinity. That's one way to write it. We could also write it using an inequality and say that my Y values are anything that's bigger than or equal to -2. So either one of those would describe our range. Let's try number 2. So number 2 is obviously a circle. So when we look at this in the X direction, that's our domain, it only goes from here to here. So that's at -1, 2, 3. So it goes from -3 to +3. So the way I could write that is -3 to +3. Or if I used inequalities, I could say that my X is anything bigger than -3 or less than +3. For our range, we're going to look at how much it goes from top to bottom. So if we look here, it goes up to +3 and down to -3. So same thing. So our range in the Y direction is also -3 to +3. And the way we would write this using inequalities is -3 is less than or equal to Y, less than or equal to 3. Because if I read this backwards, it's saying my Y values are greater than -3, but less than +3. So that would be your answer to number 2. All right, I'm going to let you try. No, I'm going to do number 3 with you. All right, so if I scan this from left to right, notice the arrows at the end. So it never stops from left to right. So this is very similar to number 1. My domain goes from -infinity to positive infinity. Then if we think about our range, this is going to forever go down, and this side will forever go up. So my range never has a boundary either. It never stops. So my range is also -infinity to positive infinity. Every number's on that graph because it goes on forever. All right, I would like you to try number 4 on your own and number 5. So for number 4, that's very similar to number 1. Now, I'm not saying it's the exact same answer, but I would use your reasoning or what we talked about for number 1. And number 5 is very similar to number 2. All right, for number 6, if we think about domain, so going from left to right, that's going to go on forever to the right and forever to the left. So my domain is going to be negative infinity to positive infinity. My range, so I'm going to do the same thing. This is going to forever go down, and it forever goes up. So my range is also negative infinity to positive infinity. All right, on to the back. All right, for number 7, if we scan our pencil from left to right, so I'm working my way to the right, and it's going to keep going to the left and to the right. So this is another one where our domain is negative infinity to positive infinity. For our range, notice our graph never goes above here or below here, right? That y never goes above or below those lines. So if we figure out where those are, this line is at positive 2, and this green line is at negative 3. So our y values never go below negative 3 or above 2. So our y values are in between negative 3 and 2. So I can write that. Remember, we always go bottom to top or left to right. So my bottom is negative 3 and my top is 2. They both have to be brackets because they're both included somewhere on our graph, right? There's not an open circle there or anything. They're both included. So our range is negative 3 to 2. I could write that as an inequality by saying that my y values are less than or equal to 2, but they're greater than or equal to negative 3. So either one of those ways to write the range would work. All right, I'm going to have you try number 8 on your own. On number 9, we have this straight line up and down right here, right? So I didn't go left or right at all. It's literally in one spot on the x-axis, right? It didn't go left or right at all. It's just right there. That value is 2. So your domain is literally just x equals 2. Or you could write it like this with that notation. It's just 2. For your range, this is going to forever go up and forever go down. So your range is all real numbers. It's negative infinity to positive infinity. All right, go ahead and try number 10 on your own. On number 11, we can see if we scan our pencil from left to right for our domain, it started right here. So that's at negative 2, and it goes to 1, 2, 3, 4, 5. So it goes from negative 2 to 5. But we need to look at our open and closed circles. So we have a closed circle here. So the way we would write that is using a bracket. So it'd be negative 2, 2, we said 5. But notice that's an open circle there. So whenever you see an open circle, you use a parenthesis, just like we did with inequalities. So just as a reminder, the closed circle, you use brackets. If you have an open circle, you have to use parentheses. All right, go ahead and try number 12 on your own. For number 13, if we scan from left to right, notice that arrow at the end. So that means it's going to forever go down and forever go over to the left here. So the way we would write that for our domain is it's going to go from negative infinity, because it'll forever go to the left, which is in the negative direction. But notice it stops right here, right? So that x value is at 1, 2. So it never goes past 2. but there was an open circle on 2. Oops, and I just colored it in. There's an open circle on 2. So remember, open circle means we have to use a parenthesis there. So it would be like that. For our range, notice it never goes above this y value. If I copy this thing from top to bottom, it never goes past there. Well, that's just when y is 0. So it goes from 0, and then it's going to forever go down, which is negative infinity. So our range for this one would be from 0 to negative infinity. But we write bottom to top, so negative infinity to 0. Then we have to think, is that an open circle or a closed circle? And it's still an open circle, so I put a parenthesis there. If I wanted to write these as inequalities, let's do that real quick. So for our domain, it was anything from 2 to negative infinity. So anything that's less than or equal to 2. For our range, it's anything that's below 0. Oops, that should be a y, because this is domain, or an x, because that's domain. For our range, it's anything that's less than 0. I just realized I made another mistake. It was an open circle, so it's going to be x is less than 2, because the open circle is just less than. All right, I'm going to have you try number 14 on your own. And that concludes your video on domain and range.